Assalamu alaikum. In this video, we solve some exercises that you have seen in the worksheet 2 and the worksheet 3 of this chapter. Also, we solve an extra exercise. I start with the extra exercise. Sophia is excavating a prehistoric site. She finds human bones in the ground and decides to send them for carbon dating. The carbon element is chosen to measure the age of an organic material. Carbon-14 is a radioactive isotope of carbon that is used in carbon dating. The first question asks, what is the meaning of isotopes of an element? The answer is very simple. Same elements are said to be isotopes if they have the same charge number Z, but different mass number A. In the second question, we have to name and to give the number of the constituent of the carbon-14. The mass number, which represents the number of nucleons, is A equal 14. The atomic number, which represents the number of protons, is Z equal 6. And the number of neutrons in carbon-14 is N equal A minus Z, which gives us 8 neutrons. In the given of third question, we have the carbon-14 that is decayed into nitrogen element with mass number 14 and the charge number 7, and also into unknown element donated by X. The nuclear reaction of this decay is shown here. We have to determine the type of the emitted particle using specific law. We apply Soddy's law. In the conservation of mass number, we have 14 is equal to 14 plus A. Then we can find A, which is equal to 0. In the conservation of a charge number, we have 6 equal to 7 plus Z, then Z is equal to minus 1. So the unknown particle is electron because it has mass number 0 and the charge number minus 1. So the type of this decay is alpha. The fourth question presents the decay curve of the carbon-14. As shown from the graph, the initial activity is 100 disintegration per minute. In the first part of this question, we have to define the activity, then we have to express its initial activity in SI unit. The activity is the number of disintegration per unit time. A0 is equal to 100 disintegration per minute. I have to convert from minute to second. Then A0 will be equal to 100 divided by 60, which is equal to 1.67 Becquerel. In the second part of the question 4, we have to define the half-life, then we have to determine its value using the graph. The half-life or the period T of a radioactive substance is the time after which the number of nuclei, the mass, and the activity decreases to its half initial value. From the graph, T is the abscissa of the ordinate of the half of the initial quantity. So it is the abscissa of 50 disintegration per minute, which is approximately equal to 5.7 times 10 power 3 years. In the part 3, we have to determine the age of the sample when the activity is equal to 60 counts per minute. Easy question. From the graph, the time taken to decay to a value equal 60 disintegration per minute is approximately equal to 4.7 times 10 power 3 years. The last part asks us to determine in years the time taken by the sample to lose 75% of its initial value. So we have to calculate the remaining quantity, which is equal to 25% of A0. So A is equal to 0.25 A0. I substitute A0 and then I get 25 disintegration per minute. From the graph, the time of this ordinate is approximately 12 times 10 power 3 years, or which is approximately equal to 2 periods. Now we solve application 2. This exercise was homework in worksheet 2. Document 1 represents the penetrating power of 3 different sources, while document 2 shows the deflection of these sources through 2 charged parallel plates. In the first question, we have to match with the justification each beam to its type using document 1. Beam A corresponds to alpha radiation, since alpha particle has low penetrating power as shown in a blue line. Beam B corresponds to beta radiation since beta particle has medium penetrating power as shown in a green line. Beam C corresponds to gamma radiation since gamma radiation has high penetrating power as shown in yellow line. In the second question, we have to arrange the penetrating power in the decreasing order. So, the penetration power of gamma radiation is greater than the penetration power of beta radiation or beta particles, and it is also greater than the penetrating power of alpha particle. In the third question, we have to specify the beam that has the highest speed if the three obstacles are removed and speed detector is placed to identify the highest speed. The radiation that has the highest speed is the gamma radiation, since they are electromagnetic waves that propagate with the speed of light c in air. Now we move to analyze document 2. In the first question, we have to justify why beam E and G are charged while beam F is uncharged. We can say that E and G are charged since they are attracted towards the electric plate, while beam F is uncharged since it is not attracted by any plate. In the second question, we have to match with the justification each beam to its type using document 2. E corresponds to alpha radiation because it is positively charged since it is deflected towards the negative plane. G corresponds to beta minus radiation because it is negatively charged. So, for this reason, it is deflected towards the positive plate. F corresponds to gamma radiation, uncharged, since it is not deflected. In the third question, we have to justify if the positron particle will be deflected or not if it is injected between the two plates. Since the positron is positively charged, so yes, it will deflect towards the negative plate. We solve right now the third exercise. In the given of this exercise, we have a cobalt-60 that is widely used in medicine, and especially in treatment of cancer diseases. The cobalt-60 is beta minus and it decays into nickel element. In the first question, we have to define isotopes. The isotopes are same elements that have different mass number but same atomic number. In the second question, we have to indicate what is meant by stable nucleus. We say that the stable nucleus doesn't undergo spontaneous decay. In the third question, we have to pick up from the text the stable isotopes of cobalt. The stable nucleus of cobalt is CO59. Also in question 4, we have to pick up from the text 3 uses of cobalt-60. The 3 uses are cancer radiotherapy, leveling device, and sickness gauges. In the fifth question, we have to identify the emitted particle. The emitted particle is electron, E0-1, since cobalt-60 is beta minus emitter. In the question number 6, we have to write the equation of decay of cobalt-60. The cobalt is decayed into nickel with the emission of an electron. We have to determine the constituents of the nickel nucleus. We apply Soddy's law. Using the conservation of mass number, we get A equal to 60, and using the conservation of charge number, we get Z equal to 28. In the given of question number 7, they tell us that the decay of the cobalt is accompanied by emission of gamma radiation. So, due to what is this gamma emission and what is its nature? The gamma radiation are emitted because the daughter nucleus, which is nickel, was born in the excited state. When it de-excites from high energy level to low one, it emits photon called gamma. The nature of this radiation is electromagnetic waves. In the given of question 8, we have a cobalt source that is used to treat cancer tissue. This source produces 6 × 10⁸ disintegration per second. And in each disintegration of cobalt, an energy of 5 × 10⁻⁻13 joule is produced. the tissue absorbs 90% of this energy. In part 8.1, we have to determine the energy absorbed by the tissue in 1 second. So it is equal to 90% of the energy liberated of an disintegration. So it is equal to 0.9 times 6 10 power 8 times 5 times 10 power minus 13 joule, and we get 2.7 times 10 power minus 14 joule. In the given of part 8.2, they said that the tissue become dangerous if it absorbs energy exceeds 2.7 joule. We have to calculate the maximum duration of this treatment in which the tissue doesn't enter in danger. We know that the energy absorbed by tissue in 1 second is 2.7 times 10 power minus 4 joule. And in time t max, it absorbs energy equal to 2.7 joule. We make the calculation, then we get 10 to the power 4 seconds. The graph of variation of the remaining percent mass of a cobalt-60 sample as function of time is presented in document 1. In part 9.1, we have to calculate the half-life of the cobalt-60 using the graph. We know that the half-life is the abscissa of the ordinate that has value equal to the half of its initial value. So the half-life is t equal to 1 times 5.27 years, which is equal to 5.27 years. In part 9.2, we have to calculate the initial mass of the cobalt sample, knowing that the remained mass at t equal 21.08 years is 0.625 grams. First, we have to calculate how many periods do we have in this time t. This t is equal to 4 times the half-life t. So the number of decay is 4. But we know that the remaining mass is equal to m0 over 2 power n, and n is equal to 4. So m0 is equal to m times 2 power 4. I substitute the value and then I get 10 grams. At the end, I recommend from you to watch this video many times and try to solve these exercises again. Wassalamu alaikum wa rahmatullahi wa barakatuh.